let's go back to looking at the example of a quadratic function. So in this case, we have a quadratic function, x squared minus 6x plus 10. Now, if we let f of x this equals 0, we get the quadratic equation in standard form. And we can use any method to solve for this. In this case, I'm using the quadratic formula. And when we substitute in the quadratic formula, we end up with a negative in the square root, which if you are in algebra 1, you will have no solution. Or if you are in algebra 2, you could say that the solution is imaginary. And this just means that the function will not touch the x-axis. If you were to graph this function, you will notice that it will never touch or cross the x-axis. However, what if f of x is equal to 5? So if f of x is equal to 5, so we're now looking at a line in here. So f of x equal 5. There's a line. If we imagine a line in there, there's a line there. So if f of x is equal to 1, we can set up the quadratic function into standard form, and then we can use the quadratic formula. In this case, we get two real solutions. So in this case, we know that if we look at the graph at 5, we know that when x is equal to 1, the function will probably be equal to 5. And when x is equal to 5, the function will be equal to 5 too. So it means that the line of f of x equal to 5 will be a solution. The graph or the function will cross that line of f of x equal 5. So that's more or less what I mean by my previous video, is that even though there might not be solutions or imaginary solutions for the zeros for f of x equals 0, there might be other values of f of x that there might be a solution for the quadratic function, where you may find a solution. So, but if we just look at an equation, because an equation already have the preset value, you can change it, but a quadratic function do have other solutions, not necessarily a 0 solution, but you can find a solution at other values of f of x. So, and again, it's just by looking at the line. That line will cross the graph, so there's a solution at that value of f of x. There's a solution because it touches the graph, and it's similar to analysis that you do when you have a system of equations of a quadratic function and a linear equation. Anyway, that's all I got. If you have any comments or questions, feel free to post them. So, hope you like this video.